Hello, everybody. Welcome to the presentation. Are you a layer nutritionist that formulate diets for laying hens? Are you looking at your formulation to understand your fourth or fifth limiting amino acid in the diet and how they improve your laying hen performance and health? In most of the cases, if you are using corn or soybean meal based diet with some other alternate ingredients, valine, isoleucine, or tryptophan could be your fourth or fifth limiting amino acid in the diet. In this presentation, we will take a deeper dive to understand how balancing that branch chain will improve performance and health of your birds rather than looking at valine and isolation in a separate silo. So, what do we have to look at when we look at valine and isolation to understand in our diet? Rather than looking them separately, we have to look them together as branch chain. And when we talk branch chain, it's not only about valine and isolation, it's also about leucine and how that plays a role in your diet. So when we understand branch chain, the valine, isoleucine, and leucine comes together. The reason they come together is the first two steps of their catabolism, where they use transaminase enzyme or dehydrogenase enzyme, they use the common enzyme to get catabolized in the body. So if there is any excess of either leucine or isoleucine or valine in the diet, it is going to degrade the other two as well, and it could cause a limited availability of the other two essential amino acid in your diets, which could ultimately affect your feed consumption or performance of your birds as well. And I'll show you a couple of data in the broilers as well as in the layers to understand how we can balance those to improve our performance and productivity in the future slides. Even before understanding why that is essential for us, let's look at what is the leucine ratio in our diet so that we can understand how we balance our valine and isolation in those. If we are looking at broiler initially, the requirement for a broiler diet is on leucine to lysine ratio is about 110. On a practical diet where we use corn, soybean, and DDGS or other alternate ingredients, our starter diet formulates to about 125, grower to one about 35, and finisher about 140, 145 on digestible leucine to lysine ratio. What about in our layers? Because that's where we are interested in. In a laying hen, the requirement is somewhere about 110 to 120 in leucine to lysine ratio. In a practical diet, if we look at our ratios, the pullet, the developer, and finisher diets, the ratios are somewhere around 160 to 190, which is way higher than what our requirement for those is. And when that leucine is that high in the diets, it causes the negative antagonism and it reduces the feed intake and performance of the layers as well. So we know that in layers, the leucine to lysine ratio can range somewhere between 60 to 70 points above what the requirement for the birds are. But what could be the cause for that? And if we look at this slide here, the first one is the soybean meal. And if you look at the soybean meal's leucine to isoleucine ratio on a blue bar and the leucine to valine ratio in an orange bar, that ranges somewhere between 1.75 to 1.9. But as we shift from soybean meal towards corn or DDGS, which could be your second and third bar here, you can see that ratio changes from somewhere between 1.7 to 1.8 to all the way to 2.25 to 3. So what that does is it increases the amount of leucine that is in your diet, and it reduces the percentage of isoleucine and valine in that diet, which causes that leucine to be as high as we saw in the earlier slide, which tends to be somewhere between 150, 160, all the way to 190. This is not much of an issue for the diet that is predominantly wheat, because wheat is relatively better than what a corn and DDGS diet is. So if we look at an Asian diet or American diet or Brazilian, South American diet where corn and DDGS and soybean meal are predominantly used in the feed formulation, branch and antagonism tends to play higher in those diets. So if you are a nutritionist from that area, definitely this is of interest for all of us. what exactly is the antagonism then? We talked about there's a higher leucine in the diet. We also talked about our regular leucine is so high in both broilers as well as layers. But what does it do? So let's look at a couple of data on what we see when those interactions take place. So this is one of the trial that we did at University of Arkansas with Dr. Keed. And here, this is the third trial that we did out of the series of trials that we did on branch chain. And here, what we have already known is valine is a bigger driver of body weight gain for broilers than isoleucine when the leucine was high in the diet. So we ran a three-way interaction looking at 5 levels of valine, 2 levels of isoleucine, and 2 levels of leucine. So if you can see here, your leucine is about 115 and 145. 115 because 115 is the recommended guideline. 145 because that is a practical leucine to lysine ratio in 28 to 42 day of age birds diet, especially for the broiler side. And then isolation, we went from 62 to 70, and valine, we range from 60 all the way to 88 to see what the performance difference comes. So when we look at the performances here, on your x-axis, you have a dietary valine to lysine ratio. On the y-axis, you have a body weight gain. On the orange bar, you can see your leucine to lysine is 115, or your green graph, your leucine to lysine ratio is 145. So I want to draw your attention to where that blue circle is, which is right at 60 valine to lysine ratio. And if you look at the body weight gain between those two lines, the orange line versus a green line, there is already a body weight gain difference. And that difference is just because your leucine to lysine changed from 115 to 145. What that means is as your leucine to lysine increases in the diet, you have to adjust your valine or isoleucine, otherwise you are going to lose a performance. And if you follow along that brown orange line, that orange line gets higher, that gets higher as we increase the valine to lysine ratio. So if we go from valine to lysine ratio from 60 to 67 to 74, you can see that body weight gain maximizes on 115 leucine to lysine ratio. But if you look at that green bar, that is still going lower than what the orange bar is. And you have to have your valine to lysine ratio to about 79, 80 to get the same body weight gain differences than what you got in 115. So you have to change about 3 to 4 points of valine to lysine ratio in order to get the same amount of body weight gain if there's a difference in leucine to lysine ratio in the books. The next example we can see is a study that we did with another type of broiler birds. And in this study, we looked at 5 levels of valine to lysine ratio, 5 levels of leucine to lysine ratio, and 5 levels of isolation to lysine ratio. And we looked at the three-way interaction of the three branch chains. We selected this 0 level, which is 75, 148, and 63 as a practical diet for our regular corn soybean meal-based diet. Valine right at 0 at 75 because that's the recommended guideline and our practical use. Isoleucine to lysine at 63 is the same. If you look at leucine to lysine ratio, which is the second column, 110 is the requirement for the bird. We kept 148 for 0 because that is a practical leucine to lysine ratio in most of the diets. So when we look at those three-way interaction with 20 treatments in a central composite design, this is what we found out. When you look at body weight gain, if you look at the first picture on your left, you can see leucine to lysine ratio is 110. And every picture you see here, there are 5 pictures, and every picture is a leucine to lysine ratio differences. The first one is 110, the second one is 130, the third one is 150, the fourth one is 170, and the fifth one is 190. When you look at those 5 graphs, what you see is the center or the bullseye is where you want to hit to maximize the body weight gain. And as you go from the first bar graph or the first picture to the 5th picture, you can see that that red bullseye vanishes in the second picture, and that bullseye moves towards your right and lower, which means that as the leucine to lysine ratio changes from 110 to 130 to 150 to 170, you have to adjust your valine and isolation ratio, or you have to increase your valine and isolation ratio because your leucine ratio in the diet had changed. So all three of them are working together to balance or maximize the body weight gain. It is not only about performance and body weight gain. Branch and amino acid also works equally in feathers and bone structure, which are very important to the layers. On the Arkansas trial that we ran, about 30% of the birds had feathering issues. When they have about 13% valine deficiency, you can see the upper two picture of this broiler is a low valine diet. And the lower two picture are a normal valine diet fed birds. And you can see about 13% valine deficiency causes a ragged feather. The feathers are concaving away from the body, and they are ruffled feathers as well. This can cause higher feather picking. This can cause cannibalism issue if you have a cage-free laying hen facilities. And it is also a feathering issue for most of the layers if the branch end is not balanced. If you look at a second picture here, this is another study from Australia, and those three pictures are deficient valine or isolation or leucine respectively, as you see the first to third picture. And you can see how the feathers are disoriented when there is less branch end in the diet or the branch end are not balanced. But why does it cause, or why is it caused? We ran one of the study where we had that three-way interaction of isolation, valine, and leucine. And what we found out was, as the leucine to lysine level changes from 110 to 145 to 190, methionine really doesn't change in the feathers. But what does change is the cysteine. If you look at a picture on your left, that is a leucine to lysine ratio at 110. You can see cysteine deposition is fairly better in every part of the corner, which means every level of isolation and valine. So it's more forgiving. But as the leucine to lysine ratio changes from 110 to 185, where most of the layers fall into, that cysteine deposition changes drastically. So if your valine is really low in the diet, or if your isolation is really low and imbalanced, you have a really low cysteine deposition in the feathers, which can cause ragged feathers. But as we increase that amount of valine or isolation in the diet, that green bar or that green color in your right gradually changes towards red, which means that there is higher cysteine deposition in the feather. If we go back and look at a paper from 1992, a paper from Farron and Thomas, they explain exactly what we saw in our recent study in 2020. I would like to draw your attention here on your left. BCD is a branch and deficient diet where all the three levels are lower. Then VDD is a valine deficient diet where we are increasing a leucine and isoleucine but decreasing valine. So it causes an imbalance on the branch end. And then VSD is a valine supplemented diet where all three of them are higher than the BCD and are balanced as well. So let's go back and look at the table on the right, and let's highlight those two red boxes that I have highlighted. The last one is the CP, which is a crude protein. And if you look at a VDD, which is a valine deficient diet, which is a branch and imbalance diet, the crude protein is only 82.7% in the feathers, which is lower than BCD. BCD is all three of the branch end are lower but balanced. And then in the third column, you see VSD, which is the valine supplemented diet. All three of them are higher and balanced. That crude protein in the feather goes up to 88. What it tells you is it is better to have all three of them lower but balanced rather than having a high leucine and isoleucine and not balancing that with valine, or having too much leucine and not balancing isoleucine and valine, which usually is our practical diets because we have too much leucine in the diet. And then when we balance all three of them by improving or increasing that leucine, isoleucine, and valine, your crude protein deposition in the feathers increases. So that goes from 82 to 85 to 88, which means that you have a better feather. If you look at cysteine, that tells the same story. VDD, which is a valine deficient diet, which is an imbalanced diet, it has about 7% cysteine deposition. But as soon as we balance that valine, where the branch ends are balanced, that goes to 8.6. So there's 1.6% differences in cysteine deposition just by changing the balance of the branch end, which was exactly what I showed you in the earlier slide as well. So let's go back and look at what in the bone structures as well. About 30% of the birds that we saw had feather issues. About 10% of the birds or the broilers that we ran our trial had some bone development issues, which was very interesting to us. And if you look at the pictures, some of the time we say this is either a vaccine reaction or calcium and phosphorus deficiency in layers. But in fact, some of the time, if we are not balancing leucine in the diet through either isolation or valine, we can have lameness problems. If we look at another picture here, which is the spinal development of the birds, a normal bird on your left and a scoliosis or valine deficient bird on your right, you can clearly see the color of the skeletal tissues. On the left is really calcified. On your left is more cartilaginous. And there is also scoliosis on the spinal development of the birds. But why would a branching imbalance causes those? So we went back and we look at this slide here. This is a paper published in 1992 again. The BCD, VDD, and VSD is the same as we discussed earlier. BCD, a balanced branch chain, but lower. VDD, imbalanced branch chain, where valine is lower. Then VSD, where all three of them are higher. If you look at those four pictures, the first one is the dry bone percentage to body weight. And you look at the first graph is the branch chain deficient. The dry bone percentage to body weight is lower in a valine deficient diet compared to both of them. So I would rather have all three of the branch chain lower than having too much leucine or too much isolation or too much valine, which could hamper my dry bone percentage. Then as I added valine to that diet, that dry bone percentage went up as well. If you look at the second picture on your right, which is a bone ash percentage to dry bone, it follows the similar trend. It is better to have a branch chain deficient diet than have higher leucine and isolation diet, which is deficient in valine or isolation or imbalanced diet. And then once you supplement all of them, you have a better bone ash percentage. If you look at the third picture, bone calcium mg per gram per dried bone, it follows the similar trend. If you balance all of the branch chain with higher leucine, isolation, and valine is required by the birds, you get a better bone calcium percentage compared to having a deficient or imbalanced branch chain in the diet. Why does a calcium changes as we change the branch chain antagonism? And this data, the fractional excretion of calcium in urine, is very interesting. As the branch chain gets imbalanced into the diet, there is more excretion of calcium in the urine, then it goes back to the blood through reabsorption in the glomerular filtration cavity. So what that does is no matter how much calcium you supply in the feed, that is going to get wasted either through excretion in the urine or feces, so that calcium doesn't go to the bones or feathers and create what it needs to create. So let's go back and see why it is extremely important to us. It is extremely important to us because if we look at the leucine to lysine ratio, where the requirement is on your second column, and where we have for pullet or developer or picking or layers, it is way higher than what we need. We need only about 110 to 120, and we formulate somewhere between 160 to 190 on leucine to lysine ratio for layers. And that causes the antagonism of branch chain. But what is the effect on the performance? Let's look at a couple of layers data. This is a study from 2015 where they have done a Highline Brown 40 weeks of age. They ran the experiment for about 60 days. They added 5 levels of valine, one a regular diet or a control diet. Then they added 1, 2, 3, or 4 grams per kg of valine, and they wanted to understand what does valine supplementation do to laying hens in terms of performance. If we look at this diet and understand where they are, the lysine is about 7.2 grams per kg. The leucine is about 13, valine 6.9, and isolation 6.2. When I run that in ratio, which is the green letters and the third column here, ratio to lysine in the diet, the leucine to lysine ratio is about 180, which is the number that we discussed earlier in the field. Valine leucine to lysine ratio in the basal diet is 95. That is way higher than what a practical diet would be. Practical diet somewhere is between, the recommendation is somewhere at 88. Some of the practical diet could be somewhere at 85. So we are already 10 points below on valine than what we are in this study. Isoleucine to lysine ratio is at 93 in this study. And in some of the practical studies, isoleucine is right around 75 to 80. So we are way above what we are already in the basal diet. When we look at the parameters, when they added alvaline from 0 to 1 to 2 to 3 to 4, most of the better performance, or we saw a quadratic response, and most of the maximum performance was when they added 2 gram per kg of valine in the diet. They had an improvement in hen egg production. They had an improvement in egg mass. The feed intake went a little higher. They had a better egg cell quality as well as egg quality. And they looked at the blood measurement, especially glucose or total protein or albumin. And all of them were better as they increased that valine up to 2 gram per kg. And then it went back down again. So it had a perfect quadratic response. But what is even surprising is if you go back and look at what the initial basal level diet's valine ratio was, it was already 93. So we are adding even more valine to what is already there, and we are still seeing a response. The reason behind that is because your leucine is already 180 in that diet. So as the leucine increases, that higher valine kind of balanced their branch chain, and it helped the diet or the birds to improve their performances as they go there. But as we go from 2 to 3 to 4, which is the last column, then the performance starts to go down. And it perfectly makes sense because now you have too much valine in the diet and you have little isoleucine and leucine to balance that. So you see the idea, it is more about balancing those three, balancing the leucine, isoleucine, and valine to get a maximum performance rather than having too much leucine or too much isoleucine or too much valine into the diet. So balancing that is extremely important. Let's look at another study. This is a study done in white leghorns. This is a little bit of older study, but it really proves a point on why and what the balance branch and amino acid does to laying hens. They picked a bird which was about 30 weeks of age, and they ran about a 60-day trial. They ran 5 experiments, and they used mostly corn, soybean meal, and they added different amino acid and minerals to balance those. In the next slide, let's look at the graph or the table on your left, which is table 2. This looks at the effect of excess leucine and how isoleucine supplementation changes the rate of egg production. There are 2 boxes that I've highlighted. The upper one, it adds about 0.3% of isoleucine into the diet. Then in the second graph, where I've not highlighted, it adds about 0.7% of leucine into the diet. So look at the rate of egg production there. That rate of egg production, as we increase that isoleucine, the rate of egg production goes from 61 to 74, which helps because isoleucine may be or could be a force limiting there, and it was helping to balance their branch chain. But as I added 0.7% of leucine into the diet and I removed that isoleucine, my egg production went down to 41%. Why? Because I already had excess leucine in the diet. Now I am adding too much leucine, but I'm not adding isoleucine or valine to balance that branch chain, and my rate of egg production suffers, my egg yield suffers, my body weight gain suffers, my feed intake suffers as well. Then on top of that 70% or 0.7% leucine, if I add 0.3% isoleucine back, from 41%, I can take that egg production to 67. So I'm improving my egg production, but I'm not going back to 74%, which was originally when I didn't add any leucine. So you see the point here, it is more about balancing that. You added leucine, we already had so much leucine in our diet. Now it affects the rate of egg production, it affects the body weight gain, it affects the feed intake. You add isoleucine into the diet, now you are trying to balance your branch chain, you get your egg production back, you get your feed intake back, and you get your body weight gain back as well. Let's look at the second, which is table 3 on your right. Here, what the author has done is they are looking at the different leucine level to different isoleucine level and understanding, is table 2 or that first experiment a fluke, or are we seeing it a consistent response? So what you see here on the table on your right is, as you are not adding any isoleucine or leucine, that rate is about 45%. Then as you add isoleucine into the diet to rate of 0.15%, that rate goes to 78%, or that egg production rate goes to 78%. Then if I keep my isoleucine level to 0.15, but add leucine gradually to 0.5 or 1 or 1.5%, my rate of egg production gradually goes down. And when I reach to isoleucine of 0.15 and leucine of 1.5, my rate tanks down to about 60%. So I went from 78% egg production when I added 0.15% of isoleucine to getting only about 60% egg production when I added extra 1.5% leucine but kept isoleucine constant. Why did that happen? Because I added too much leucine in my diet. Now I had branching antagonism. That affected my body weight gain, that affected my intake, and that affected my egg yield and production as well. But if I keep my leucine to 1.5 and then I increase my isoleucine to 0.3%, then that 60% egg production goes to 80%. So see the difference? By doubling the amount of isoleucine from 0.15 to 0.3% and keeping that leucine constant at 1.5%, my egg production went from 60 to 80. Why is that? Because I added isoleucine and now I'm balancing that leucine, which is too high in the diets. And if I go back further and I keep my leucine to 1.5 at constant, and then I increase my isoleucine to 0.45% from 0.3%, my egg production goes to 76% again. So it's a 4% drop. Why is that 4% drop? Now I have too much isoleucine in my diet. So leucine is not only a negative effect, isoleucine will also have a negative effect if you do not balance that properly. So the key is balancing, looking at how much leucine you have in your diet and making sure you balance your isoleucine and valine accordingly in your laying hen diet so that you can get the maximum performance. This is the last slide that we will talk about. And you can see the same response here. If you look at isoleucine and valine and leucine interaction on the percentage of lay, as we change that isoleucine or valine or leucine into the diet, that rate of egg production changes as well. And when we add more isoleucine and valine, your egg production goes from 50 to 59, 72 to 74. So you have a highest egg production there. So balancing all of that is extremely important. And table 5, which is the last experiment, it exactly tells the same story that I had earlier as well. It is looking at valine and isoleucine and how when you have about 1.5% leucine in the diet already, and how you have a valine and isoleucine interaction, and how that changes the rate of lay. You can have a rate of lay somewhere between 17, 18%, all the way to 70%. And that is just by balancing and playing around with the level of valine and isoleucine. So understanding where is the optimum level of valine and isoleucine then, if you look at the Bergendahls paper on your left and Wen et al.'s paper, which was published in 2019 on your right, one of the papers says it's about 93%, and one of the papers says it's about 89%. And the whole reason or whole difference is if you look at leucine and lysine differences on that diet, on the right, where the optimized egg mass is 93% for valine, the leucine to lysine ratio is at 184. When you see an optimized egg mass valine to lysine requirement at 89, the leucine to lysine ratio is at 116, which exactly follows with what we discussed earlier. If you have a leucine to lysine ratio at 116, you only need about 89 ratio of valine to lysine. But if your leucine to lysine changes to 180 or 185, then your valine requirement to optimize that egg mass can go up to 93 or 94 or 95, depending on where your leucine to lysine is. And that completely reflects to what the Brazilian table and some of the requirement guideline tells. If you look at isolation requirement falls somewhere between 79% to 85%, depending on what your leucine to lysine ratio is and what you are trying to maximize. So what do we learn from this in a nutshell? If we have to break it down to three different topics, what we understood today is as the bird ages, depending on what ingredient you are using, the dietary lysine can be typically higher in a diet. And if we can balance that dietary leucine to lysine ratio by adding either valine or isoleucine, then that can improve our egg production, egg performance, feed conversion ratio, feathering, and bone health as well. Thank you for your time.